Hello everyone, welcome to this part 7 video of Form 3 Mathematics, Chapter 6, Angles and Tangents to a Circle. So in this video, we're going to solve some problems involving tangents to circles. So there's one concept that you need to know before we look at the example questions here, which is common tangents. So what is common tangents? A common tangent to two circles is a straight line that is a tangent to both of the circles. For example, right now I have a circle here and at a second circle. If I draw a line and then I have a line here, and if this line happens to be the tangent for this circle and this circle, for both the circles, this is a common tangent to these two circles. And now we have another line here. So if this straight line happens to be the tangent for this circle and this circle at the same time, hence we call this line a common tangent to these two circles. Actually, there is another common tangent where we can draw, which is in between the two circles here. So if this line happens to be the tangent for this circle and the tangent for this circle, this is also a common tangent. And of course, we have another one here. So if we have two circles of the same size, we can draw 4 common tangents. How about other combinations of circles? If now I have one big circle and one small circle of different sizes, how many common tangents can we draw? So actually we can have 1, 2, 3, and 4 as well. Then we have circles which are together. Okay, for this case, we can draw 1, 2, and 3 common tangents. If we have now 2 circles together with different sizes, we can also draw 3 common tangents. How about circles which are overlapped? For this, we can only draw 2 common tangents. And if we have overlapping circles with different sizes, these two have 2 common tangents. Then for the last one, we have this. But for this case, there is only 1 common tangent. Okay, because this line here is a tangent for the small circle and a big circle. Hence, this is a common tangent as well. Now we try to look at example number 1. Given 2 circles with center O here and center Y. And for this, we have radius 5 centimeters. For this circle, the small circle, we have radius of 3 centimeters. Determine the value of x. Find the angles x here if PQRS is a common tangent to both circles. If PQRS is a common tangent to both circles. So we try to fill in the values for the sides and the angles here. So since this is the radius for the big circle, which has a 5 centimeter, and this we have 3 centimeters here. So the total from O to Y is 8 centimeters. Okay, 5 plus 3 here, we have 8. And with this information, we can redraw the polygon here such that we have this. Okay, 8 is from O to Y. YR is the radius of a small circle, 3. OQ is the radius of the big circle here. Okay, this is 5, this is 3. Since QR is a common tangent, so we know that this angle here is 90 degrees, 90 degrees. So right now, if we draw a line which is parallel to the baseline here, QR, here, okay, we form a right angle triangle. Okay, right angle triangle, because since 90 degrees, if this line is parallel, here it will be 90 degrees as well. Okay, so this is a right angle triangle. Since we know that the length for this is, for OQ is 5, so if 5 minus 3 here, we get this is 2 and this is 3. So for this triangle here, which is denoted by the blue lines, this is a right angle triangle, and with the side 2 centimeters, 8 centimeters as a hypotenuse here. In order to find x, we can use trigonometric ratios. So if we take this angle here, this side will be the adjacent side. This side will still be the hypotenuse because it's the longer side, which is opposite the 90 degrees here. Okay, so which trigonometric ratios, which is the sine, cosine, and tangent, involves adjacent side, because this side is adjacent to the angle, and a hypotenuse? It is cosine. Cosine equals to adjacent side over hypotenuse. So the theta here is the x. Adjacent side will be 2 centimeters. Hypotenuse will be 8 centimeters. So cosine x equals to 2 over 8, which is 1 over 4. In order to find x, we find the cosine inverse of 1 over 4. Hence, we have 75.52 degrees. Example number 2. A wooden stick is placed onto a tire which is lying on a flat floor. So here, this line here, CB, represents the flat floor. Given the diameter of the tire is 60 centimeters and the distance of AB from point A, where the stick touches the tire, from A to B, where the stick touches the floor, this is 1 meter. Determine the distance of BC, and also determine the distance between the center of the tire, which is this point here, the center, and the point B. We find the distance here. So we can actually redraw this diagram here so that it forms something like this, where this is the point A, where the stick touches the tire, B, the stick touches the floor, BC is the floor. Okay, since the tire is lying flat on the floor, we can say that BC is the tangent to this tire. Since the stick also lays on the tire at one point here A, this line here AB is also the tangent. Given AB is 1 meter, we are now looking for BC. So according to the properties that we've learned, whenever you have two tangents of the same circle touches or intersects at the point B, AB equals to BC. They have the same length. Hence BC equals to AB equals to 1 meter. So the second question here is we need to find the length from the center until B. So if we draw the line, center with the center O here, this is the line, this is the length that we are looking for. Okay, so now if we take this side here, remember this line AB is a tangent, hence if we connect A to O, we will form a right angle triangle. AOB is a right angle triangle. AB we already know is 1 meter from the question, and the radius is also given in the question. O here is 60 centimeter is given in the question. So this is a right angle triangle. If we want to find OB, which is the hypotenuse, because hypotenuse, this is the longer side which is opposite to the right angle, okay, we can use Pythagoras Theorem together with side AB and OA. Okay, so OB squared, according to the Pythagoras Theorem, equals to OA squared plus AB squared. So now you look at the units here. This is centimeter, this is meter. So we need to change one of these. Okay, so OA, we change the 60 centimeters to meters by dividing 100. So 60 centimeters becomes 0.6. 1 meter is still 1. Then we find the values 1.36, and then in order to find OB, we find the square root of 1.36, which is 1.17 meters. Example number 3. Diagram shows two circles with center O and P. AD and BC are common tangents to the two circles. Okay, so AD here is a common tangent for these two circles, BC is the same. Given OA is 5, so OA, the radius for the big circle is 5. CP, the radius for the small circle is 3. Give your answers corrected to 4 significant figures. Calculate the value of x. Find the values of x. Then we find the length of this later. So we start off by finding the values of x. So for now, the only angles that we have is here. We try to make use of this information. So we look at the diagram again to find the values of x. First, we try to fill in other informations given. Since we know that AD is a common tangent, hence OAD has a value of 90 degrees because AD is a tangent. Here 90 degrees because BC is also a tangent. Here is also 90 degrees. Here 90 degrees as well. Okay, then we come to this AOBE. AOBE is a polygon. So the total interior angles of this polygon, this four-sided quadrilateral, is 360. Hence, if we want to find this angle, we take 360 minus 90 minus 90 minus 120, we can find this angle. Okay, so in order to find AEB, we take 360, which is the total interior angle for quadrilateral. We minus this 120, we minus 90, we get this, which is 60. So you know that this is 60, and this angle are vertically opposite angles because the line here are straight lines. So this angle here and this angle vertically opposite means they have the same value. They are equal. So this angle 60 means this angle is also 60 degrees. We can also find x, where we take 360 minus 90 minus 60 minus 90, you get x. So x equals to this, and you get 120. So you will find that x here actually has the same value as 120 over here. Now we look at finding the length of AE, CE, and OP. AE is from here to here, A to E. If we draw a line from O to E, according to these blue lines here, we have a right-angled triangle, where this angle here is 60 because it's half of 120. Here we have 30, half of 60. So if we take this angle here as our reference angle, so we redraw this, the 120 here we divided by 2 becomes 60. So the 5 centimeter becomes the adjacent side of 60. This side becomes opposite side. So AE here is the opposite side. So which trigonometric functions involve adjacent side and opposite side? Is tangent. Tangent 60 equals to opposite side over adjacent side. Opposite side is AE. So here AE. Adjacent side is 5 centimeters. So we solve this, we move the 5 here, so AE equals to 5 times tangent 60. Use a calculator to get the value, which is 8660 corrected to 4 significant figures. Now we know AE is 8.660. We are looking for CE. Okay, CE is here. So actually we just apply the same method, only this time we are using this triangle here, which is a right angle triangle. X is still the same, it's 120, so the half of this is 60. 3 centimeters is adjacent, this is opposite. So tangent 60 equals to opposite over adjacent. Opposite is CE, adjacent is 3. Move the 3 here, CE equals to 3 times tangent 60. Use your calculator, you get the answer. Now for the last part here, we have OP. We are looking for this from O to P. So actually OP involves these two triangles, AOE and CEP. Previously we already find the values for AE and EC. So since this is a right angle triangle, we just use Pythagoras Theorem to find OE and EP, and then we total up the length. So we go to AOE first for this right angle triangle. OE squared equals to OA squared plus AE squared. 5 centimeter squared plus 8.660 squared. The square here, I move to the other side, becomes the square root. Use your calculator, you get the answer 10 centimeters. So we know that OE is 10. By using the same method, now for this triangle here, the smaller triangle, EP squared equals to CE squared plus CP squared. In the values, I get EP equals to 6 centimeter. So EP here is 6. So from O to P, I just need to add up OE plus EP. 10 plus 6, which is 16. So OP equals to 16 centimeters. Angles and tangents of the circles. So now we go to the last part of this chapter, which is solving problems involving everything you learn, angles and tangents. Now we go to example number 1 here. You have two circles with center O and Q. RS is the common tangent for the two circles. Determine the value of x. So now we have 100 degrees here for this angle. In order to find the x, we try to find the angles for the other parts first. So we try to examine this diagram again. So since RS is a common tangent for both of these circles, hence this angle here is 90 degrees. This angle here, OSR, okay, this angle here is also 90 degrees because RS is the common tangent. So now, if we know that this is 100, this is 90, this is 90, we can find the value of this angle because the total interior angle for a quadrilateral, four-sided polygon is 360. So 360 minus 100 minus 90, you get this. Meaning that SOP here, this part here is 80 degrees. And for this triangle here, you notice that because OP and OS are radius for the same circle, hence they have the same length. So this is an isosceles triangle. And we know that this is an isosceles triangle. Isosceles triangle has the same base. X here, it has the same value here. So if we take 180 minus 80 here, and we divide by 2, we get the values of x. So x equals to 180, the total interior angle, minus 80, divide by 2, because these two base angles here have the same value. So you divide by 2. Hence you get 50 degrees. Example number 2. Diagram shows two circles with center O and center P. Tsr is the common tangent to both circles. Determine the value of x here and y here, and also the length of rs. Okay, so the first thing here is, since the rst here is a common tangent, meaning that tso for this angle here and trp, this angle here, are 90 degrees. Here, this angle and this angle are 90 degrees. And since they are 90 degrees here, so this line here, OS and PR, is a pair of parallel lines. Because both of these forms a 90 degrees, the same angles to the common tangent. Hence, RP and OS here is a pair of parallel lines. So whenever you have another line here, TOP, which intersects with this pair of parallel lines, it forms another pair of corresponding angles, which you learned in the previous chapter. Okay, so this angle here and this angle here is called a pair of corresponding angles, and they have the same value. Hence, we know that this is also 60 degrees. And if we know that this is 60 degrees, we take a look at this triangle here. Since RP and PQ are the radius of the same circle, they have the same length. Hence, this is an isosceles triangle. From the 60 here, we can find this value, which is 120. And from the 120 here, we take 180, which is the total interior angle, minus 120 divided by 2. You get the value of x. So x equals to 180, which is the total interior angle for this triangle, minus 120. 120 is here. Okay, this is 120 here, and divided by 2, because this angle and this angle is the same, both are x. So you divide by 2, you get x, which is 30 degrees. After you know that this is 30 degrees, we also know that this is 30 degrees, because these two have the same value. So if you know that this is 30 degrees and this is 90, because this is a straight line, which is 180 degrees here. In order to find y, we take 180 minus 30 here, minus 90. Okay, so y equals to 180 minus 90 minus 30, because this is the angle of a straight line. So y equals to 60 degrees. Next, to find rs, we need to use the triangles formed from TSO and TRP, like this. Okay, notice that since this is 90 degrees, TSO is a right angle triangle. TRP is also another right angle triangle, because TSR is the common tangent. Okay, so 60 here is this, 60 here is this. 3 cm the radius will be the length of this side, 6 cm the radius will be the length of this side. So if you want to find rs, we find RT minus ST to find rs. Okay, RT minus ST, then we can find rs. Okay, we look at respective triangle. For this triangle here, in order to find TS or ST here, according to this angle here, the reference angle, this will be the adjacent side, this will be the opposite side. So we are using tangent, because tangent involves opposite side and divided by adjacent side. So tangent 60 equals to opposite side TS divided by adjacent side, which is 3. To find TS, we take 3 multiplied by tangent 60, we get 5.196. The same applies to this. Tangent 60 equals to opposite side TR divided by adjacent side, which is 6. To find TR, we move 6 here, becomes 6 multiplies tangent 60, you get 10.39. So in order to find RS, we take the longer side here, RT or TR, minus TS. We get 5.194. That is the final answer. So this concludes chapter 6. I'll see you in the next video. Thank you everyone.